My name is John Peterson. I'm the co-CEO and co-founder of a cybersecurity company called Pre-Security. Pre-Security is revolutionizing security operations by delivering native artificial intelligence solutions into a platform that can predict cyber attacks before they happen and detect cyber attacks with more fidelity, as well as triage logs faster than any human can do. Our solution is a cloud-based solution. It's also an on-prem based solution. And we also have appliance-based solutions that are ideal for managed security service providers that want to roll out security services for small to medium enterprises. But our solution scales from the smallest customer to the largest organization. What you're looking at here is the user interface for our AI-Native SecOps platform. The platform is powered by a cyber large language model that's proprietary, and it's powered by GPUs. It does all of this processing by first collecting data from any log source without the need to have complex parsers interpret the data. Every log that comes into our system, regardless of what tool set it's coming from, it could be a firewall, it could be endpoint, it could be from some sort of cloud application. Every single log that comes into our platform is converted to natural language using our cyber LLM. The reason why converting a log to natural language is so important is because we're using a large language model to do predictive analytics and improve detections. So what you're looking at here is our dashboard. The main dashboard is kind of showing you some visual indicators of what's going on in your network. The globe is indicating attack locations. So these are locations that are showing up and plotted on a globe, giving you a visual indication of where cyber attacks are coming from in your environment. If we look to the center here, you're going to see some statistics that show how many logs have been ingested into the system. In this case, there's 78,319 logs that came into the system. Again, every single log that comes into our system does not have to have a parser to be implemented into our system. We built some technology called log to NLP, and again, log to NLP converts any log to natural language. So in this case, it's about 78,000 logs that have come in. From that, 50,000 of these logs have been processed, and then it resulted in about 9,800 detections and predictions with a reduced data rate of about 87%. The reason why this is important is because you might want to take a solution like this and put it in front of your existing SIEM and have the system act as a preprocessor of sorts. So logs come into the system, detections and predictions are made, and then the output can be sent to existing SIEM solutions, ultimately reducing the data ingestion rates of your existing tool sets. In the center here, it's showing you asset detections. These are detections based on assets that are in your environment. They could be servers, they could be workstations. We also have asset predictions. Again, being able to predict a cyber attack before it happens is very critical and important with our platform. And then user detections and user predictions and other things of sort. There's a predicted risk radar. These are things that have not happened in your environment yet, but the system is actually plotting where potential risk may be. The closer you get to the center of the radar, the higher the risk is going to be. So in this case, there's a prediction that a malware download attempt is likely to occur, and if it does occur, it's going to pose about a 93% risk to your environment, whereas things that are kind of on the outer side of the radar will clearly have a lower risk assessment. Then there's a visual indicator showing you how many logs have been processed over the last 24 hours, and then here's where we actually convert logs into natural language. Many times you'll see logs in a format like syslog or JSON format, and they're very complex and hard to read and hard to understand, and you have to have a parser usually to identify what the log is about. In this case, as you can see here in natural language, a human readable paragraph describing the top 10 logs that have come into the environment. At any point, you can click on a button like how risky is this and get more insight as to what this particular alert is all about. So we'll give it a second, let it process and analyze the... So you'll see here the natural language description of the log, and you'll also see here the result when I clicked on the button, how risky is this? As we kind of scroll down through the dashboard, you're also going to see things like top 10 asset detections, user detections, and then predictions. And if we were to take one of these, I'll just click the triage button, click on it here. It's going to give you what we call a consensus predicted event. So it's stating here that malicious IRC activity has a high probability of occurring, and if it does occur, it's going to pose 100% risk to your environment. This prediction was made based on correlating 15 logs, And then there's a prediction explanation, a summary, and a detailed analysis, and then a recommendation on what you should do about this. Now, we call this a consensus prediction because we run all of these logs and all of this data through 4 different prediction engines. One of them being the Markov model prediction, so it gave a prediction. The MITRE ATT&CK framework predictor gave a prediction. Lockheed Martin predictor gave a prediction. And a SOC expert analysis, or analyst rather, prediction was also given here. And when you take these 4 different predictions and you combine them all together, you end up with the consensus prediction. This is so that we can ensure that our predictions are as accurate as possible by simply getting a second opinion and a third opinion of the prediction. At any point, you can click on SIM data and actually see the raw logs that contributed to this prediction. There's also built-in threat intelligence feed, a prediction histogram, telling you what types of events have occurred over time. As I scroll down to the bottom here, you'll also see lots of different charts and visuals that talk about top 10 host names, top 10 IP addresses, top destinations, top IPs by risk. And then down here, you'll see something called the detections by top security tools. In this particular demo environment, there's logs that are coming in from a variety of different tools: Fortinet, Cisco Umbrella, IDS logs, web application firewall logs. And remember I said that when logs come into our system, we don't have to have a parser interpret these logs. These logs are being interpreted by our Cyber LLM, which is our proprietary large language model. Everything in our platform is driven by GPUs and a large language model. It's inferring the log source and automatically doing the parsing that normally would have to have a parser written for. So let's move into the next section where we'll do a deep dive of the product. And we're going to cover 5 different areas: data collection, observations, detections, predictions, and then we'll wrap up with interactions and a summary of the platform. So starting off with data collection. The first thing we need to do is ingest data or get data into the system. So you'll take your tool sets, could be your firewalls, could be your endpoints, and you'll point them to the pre-security platform and start streaming your log data into the system. Here you've simply set up a log receiver. Basically it's a channel report that logs are going to come in on. So in this case, we've got listener 1, 2, 3, 4, 5 set up. And if at any point you wanted to add a new listener for a different tool set, you can. But again, you don't have to have any parsers. The logs will come in on these different channels, and then the system will automatically interpret the logs based on our large language model. Once data comes in the system, processing starts. And at any point, if you want to export the data to another tool, you can do that as well. So here's the data export section. You can tell it what type of data I want to send to a different tool. For example, let's say I wanted to take these predictions and detections that are coming from the pre-security platform and then output it to an existing SIM tool that you might have. You can select what type of data you want to have exported. In this case, I've got selected user predictions, asset predictions, environment predictions. I could even stream some of the detection alerts that we come up with. And I simply point to a host that I want to send it to and a port. And then I start the export process. The other thing that's important with our platform is data processing. Here's where you can start to create exclusion lists to filter out things that you don't want analyzed. And you can also set priorities to prioritize some logs over other logs. The system also has the ability to be trained on the customer's information or data from their environment. So not only are logs coming into the system, but you could also upload a Word document. Could be a compliance document, or it could be a vulnerability assessment that you just did. And you upload that to the system, and then the system will become knowledgeable of all of that new information you gave it, and then use that information to aid in its detections and its predictions. Again, there's also a built-in threat intelligence feed that's in the system where we're identifying known bad IP addresses, URLs, domain names, and things like that. And that information is also useful in making the detections and predictions that it does. At any point, you can also upload your own threat intelligence data. If you don't want to use the threat intelligence data that comes with the system, maybe you already have a subscription for threat intelligence feeds from somewhere else, you could easily upload that here as well. And then we have new domain intelligence. So the system will learn newly registered domains and use all of that data and all of this information to aid in its detections and predictions. So let's move to the next section, which is observations. This is where our SIM comes into play. Now, we're not just a regular SIM, a legacy-based SIM. We are a AI-native based SIM. So when you talk to the SIM, you don't have to write complex queries to find information in your logs anymore. You can actually use natural language to ask it questions. For example, give me all of the alerts that have a risk score greater than 90%. Now I'm using natural language because there's a large language model under the hood that's powering all of this. Legacy solutions, you'd have to write some sort of query. In this case, the query is simply natural language. And as you can see here, it returned me all of the logs that had a risk score greater than 90%, just like I asked. At any time, I can kind of drill into the log, and you'll see here that there's a natural language text representation of the log. But as I scroll down to the bottom here, you'll see what the original log actually looked like. The original log was this complicated JSON formatted log, but the system will automatically convert that log into something that's easy for anyone to understand. The system also has the ability to generate reports. At any point, you can schedule a report to be run and get a visual indication of what's going on by way of a report. We have this concept called a log book. A single log does not have enough context to make an adequate prediction or detection. To make predictions and contextual detections, you need lots of information, not just one log. So we have this concept called a log book. I'm going to go ahead and let's take a look at the log book related to this asset. The asset happens to have an IP address called 192.168.1.1. So if I go ahead and search for that, it's going to actually return back all of the log entries related to that particular asset. And that is what we call a log book. It's a collection of logs over time for a particular asset. And then what we end up doing is we take the log book for that asset and we feed that entire log book to our cyber LLM, our cyber large language model. And the large language model will interpret all of these logs and come back with a prediction based on what it's seeing. So it might predict that there's a high likelihood of ransomware spreading in your organization simply by looking at historical trends and things like that for a particular asset in your environment. Now, the detections that we have are very different than detections you might have in a legacy or traditional SIEM. Our detections are what we call contextual detections. Contextual detections are based on correlating various logs. So in this case here, I've got a particular detection, and there were 25 logs that were correlated in order to make that detection. I could look at a different one. This one might have 21 logs. The contextual detected event here was a high security threat was detected, and it'll give you natural language summaries and detailed analysis and recommendations. It'll also allow you to kind of jump to our SOAR, which is Security Orchestration, Automation, and Response, part of the system. We call it SOAR GPT, where the system will automatically write you a playbook or rule to take the recommended action. The recommended action could be to block an IP address or quarantine a user. Those same detections that we do for assets, we also do for users. So as you can see here, there's a potential data exfiltration attempt that occurred for a particular user. And again, this was based on correlating 15 different logs from different tool sets in order to make a prediction for these users. Let's move to the next section, which is predictions. This is the part I really get excited about. Trying to get ahead of the cybersecurity problems have been very, very difficult. Detection capabilities are usually very reactionary. So something happens, you detect it, and you quickly try to respond to mitigate the threat. But what if you could actually get ahead of the problem and actually predict a threat before it actually ever happened? No different than the weatherman predicts the weather. We do that by bringing in lots of different data points over time, just like weather forecasting does. It's different data points. In the case of weather forecasting, it's barometric pressure, humidity, seasonality. In the case of our cybersecurity tool here, it's data points coming from different logs. It's logs coming from your firewall, logs coming from your endpoint, logs coming from your servers. All those things are put together, and then the system is using all of the trained information that has been fed into it to make these predictions. So let's take a look at one of these. This particular prediction was predicting that malware upload is a high probability of occurring, and if it does occur, it's going to pose an 80% risk to your environment. 60 logs were correlated again, giving you natural language summaries and explanations and recommendations, and the predictions are done based on 4 prediction models to end up with a consensus prediction. At any time, if you want to validate the prediction, you can jump into the raw data itself, and you can click on the events and manually triage this. But the whole goal of the system is to do things at a faster rate than humans can do. In this case, there were 60 logs that were correlated. Imagine how long that would take for an individual to go and look through every single individual log. But you could do that, and your human mind could probably infer a prediction. It would just take you a lot longer to do it than a system like this. Now let's talk about interactions. This is how you interact with the data. So we have something we call SOC GPT, similar to Chat GPT, except that you're talking to your own data. You can ask it questions about the logs and the data that's being fed into the system specific to your environment. So for example, let's say, give me a prediction on source countries that may attack me. And based on all of the data and historical patterns that the system has been seeing, it's coming back with a human readable response that's saying the top 5 countries that have a high likelihood of attacking your environment are China, Russia, North Korea, Iran, and Vietnam. I could also type in things like, give me the 5 most recent alerts in my environment. Just using natural language questions and you'll get back natural language responses based on your data set. So system here responded saying these are the recent alerts that came into the environment. A high severity alert, malware detection, medium severity alert, which was network anomaly, so on and so forth. We also have this capability we call SOAR GPT. So again, interacting with your data set, SOAR GPT has the ability to write SOAR playbooks. I could say something like, write me a Python playbook to block IP address 192.168.1.1 on my Fortinet firewall. And the system is going to use its knowledge of what a Fortinet firewall is and how you would go about doing that. It's giving me a breakdown of what the playbook would look like. And now if I wanted to actually give me the code, I can say, give me the Python code to run this playbook. And there you go. The system has the ability to write Python code, and you could simply copy and paste that into a script on a server and have it execute the playbook for you. So this concludes the demonstration, and what I tried to highlight here is that our system has the ability to predict cyber attacks before they occur, bring a higher level set of detections to your environment. We call those contextual detections, as well as automate log triage. If you have any questions, feel free to visit us at presecurity.ai.